Sorry for the introduction. Apologies to everyone. Sometimes settings up are just a little bit different. Thank you also for listening in English. I know there's at least 10 different nationalities in here. I have come to understand that it's actually not common for everybody to speak English, so I appreciate that we're doing that, which brings us basically to the theme of this mini report, I should say, on ongoing work that we have undertaken since February, so it's basically 6 months that I want to talk about today, which is robotic braille and patterns towards combining tactile and visual narratives. And just following on from this moment's conversation, is basically, I could have also called it from pixel to tactile literacy, or from microarchitecture to a human-centric approach. But basically what that work investigates is what does it mean to work with robots and computation? And what does it mean actually for anyone on a more global level? And what does it mean for anyone on a more general level? So this lecture here is actually a short overview about computational design, scripting, and robotic milling with the standard 6-axis industrial robot for spatial and interpretative mapping using pixels and line-based textures and patterns as information, narratives, and metatext for spaces and public areas. I would like to for people to, I don't think this clock is actually working. If someone can time me. I would like to suggest that you close your eyes. If you just bear with me for a second. Close your eyes. Feel the texture of the seat in front of you. Maybe if you dare to, and you know the person next to you, take their hand. Social interaction. Yeah. Maybe think about how it is that you're sitting in the space. Are you familiar with the space, and could you describe that space by just having been sitting in here for having accessed it for 2 or 3 or 5 minutes? So not being too familiar with it right from the outset? Yeah? Good. Now open your eyes again, and let's talk about some of the things that you might see or might experience in a slightly different manner, depending on what your capabilities were, what your physical attributes are, what your competencies are in interacting with space, with meaning, with language, and with other people. You may listen closely to people around you. Do you remember colors from your childhood? A talk, talk, talk accompanies you. Your attention to sound is heightened. You highly enjoy your distinct sense of surfaces. You're blind, or you're partially sighted. So this project is really about how we can engage robotic design and computation in a possibility in order to help people deal with their different capabilities towards more inclusive environments in build structures and build environments of the future, which we can co-inhabit and where we all can learn from each other. The difference that people do have in experiences of the environment is multisensory, and it's based on a continuous information through relationships that are dynamic and mutually influential. So it's of course dependent on how you are, but it's also of course dependent on how you can train yourself up, how sensitive you can make yourself, how much you can use your different capabilities rather than the primacy of visual engagements towards a tactile engagement with the environment, which might give you some different sorts of stimulants. So whether the human sense of touch is active, informative, and a useful perceptual system, it is actually our senses that make us, that shape us from childhood onwards. This is, of course, not something that's exclusively related to blind people, but it is something that goes for everybody from an early stage. And because, fantastically, the brain is plastic, this sensory intake and our ways of modalities of perception can be continued to be shaped across our whole lifespan. The way that our senses are actually engaging is bidirectional. And in computational design, we love to do things like top-down processes versus bottom-up processes. So this is something relative to our sensory feelings that relates back and forth between both. you deduct from a certain sensory input, you read all of that, and you play back your interactions with the world. These are different emotions that are, or the different emotions that we do feel and the actions that we take are induced in the brain and are played out, as Damasio says, in the theater of the body. Now, how do you do that when you're blind? And I put this one up here because I thought it was fantastic. If we talk about how we're reading spaces, we do that with our senses. If we talk about literacy, we take literacy for granted because we have learned in a quite extensive process between the age of 4 and 7 to learn. So we actually take reading as something that naturally occurs. Reading for blind people, or tactility for blind people, is something that embraces literacy. So what you see here is possibly the first and only comic in the history of blindness, which is produced by Philip Meyer. So you see the dot points here when we talk about the pixels here. The dot becomes the foundation for both the language and the illustration in a picture book, which deals with relatively simple notions. There's a circle, the circle meets another circle, they create a third circle, that third circle stays with them, it continues to vanish, and then at some moment only a single circle is left over. So that one comic actually displays in a blind context the idea of life. Tactility or literacy is trained similar to children with sightedness. It's trained for children with low vision or with blindness, or later on also with adults, through means of tactility. So for that purposes, we do have at our hand the possibility of swell paper, where relief images are actually put on a swell paper in a copy machine, carbon printed, and then the dedicated areas are swelling up. So what you already see here is that there's a distinction that appears in height, which is probably or relatively 2 millimeter. But the distinction that's made is actually between the patterns, between the boundaries, between the different zones that appear. The color coding here is only for purposes of the interacting seeing teacher in order to point out the demonstration material. These pictures, or the translation of these pictures, or the increase of that literacy requires an understanding of how we actually perceive images, how we understand narratives, and how we understand signs that are presented and communicated to our fellow human beings. Shades of color cannot be perceived. If a shade was represented in a tactile picture, it would be perceived in a new shape and confuse the reader's perception of the picture. In these tactile pictures, almost all figures and objects are depicted either from the front or the side, because the haptic sense can only perceive shapes which are tangible. So corners, edges, lines, differences in surfaces in the form of raised shapes become super important. So what you see here is actually one of the most, I think, more important books, or more powerful books than the Bible. This is from Harry Potter, Dumbledore, and then of course what you see is the translation of these different colors into patterns. There's not only swell paper, but there's also thermoform, which is a technique of molding plastic in a matrix using a vacuum press of high temperature. So what you see on the right-hand side is a model of that's tested through a blind user, and then on the other side you see the thermoformed outlines of a world atlas that's accessible through tactility. So this is basically teaching material that was made accessible to us in the interaction and collaboration between the Aarhus School of Architecture and the National Institute for Blind and Partially Sighted People in Copenhagen, with whom all of this collaboration is actually proceeding. Now, of course, tactility, if we talk pixels, if we talk big data, in this context here, pixels or data may refer to a Braille set. Braille is the coding language that has been invented by Louis Braille out of necessity because he was blind by a childhood accident. It's been in use for 200 years and it's still kept in its original form. It's basically the translation of a systematized 6-dot cell, which is used to spell out the different discrete characters of the alphabet. And there's, of course, national distinctions that exist for particular figures that that don't appear in any other language. But the overall Braille coding is something that's not only national, but it's global. So it's a language that exists out there, which is based on the pixelation of that Braille cell data. But not only that, but the Braille code also entails how it's computed and how it's fabricated. So there's particular dimensioning and sizing from each individual cell or pixel in that part, which should be raised about 1.2 millimeters. The distances between different points in the cell, and then the distances of spacing both between different words, as a break between different words and as a break between lines of words, so that the full text is actually developed. So that's another one of the base components. And I think I have to walk a bit harder. Sorry. This doesn't move forward. Can you move me forward? Big one. Okay, super. The last point that comes into this is, and this is basically based on human-centric design, why are we doing all of that? So, and in the way that we're doing that, can we actually make a design that's good for anyone? And whom is it good for? And how do they use it? And does it actually integrate users of different capacities? So this is heavily leaning on the idea of universal design principles, which should be universal and equitable in use, flexible in use. If we break that down towards blind and sighted people, it's basically make it safe, make it understandable, make the logic comprehensive and not blurred, make it enjoyable to touch, respect different body heights and accesses and distances, and so forth. We don't really have the time to go much deeper into this one here. But by doing so, and this is important, everybody is actually benefiting, because it sort of takes the overcomplexity out of the design towards the different possibilities of a body. Now, of course, this is combined with robotic fabrication. The idea of robotic fabrication and pixelation or different data trails is, of course, also nothing new. We've been working with that, for example, here in the facade systems in forms of laser cut holes that are punched towards a particular angle, or towards mold making, or towards injection molding in the span between 2012 and 2018. But what's interesting is that this can be relative to the images or the narratives or the stories that we tell each other in a cultural and sociological context. So here's a pixelation that's basically crafted by robotic angle and effectors and the particular way how these points are each singularly and individually formulated in order to produce that picture. We have then taken that into smaller experimental studies, which is basically a research on how different patterns can be radically and carefully crafted with a smaller ABB robot. Very grassroots, we just mounted first a Dremel and then a router with different tool bits onto the small robot. But really what's interesting here is that these pixels and that computation is nothing if it's not in the material. So the pixel code runs onto the material, and it's only the burn traces, it's the leftover pieces that actually, for me at least, make the fascination within this becoming of basically materiality. So as part of a larger series, we developed two scripts. One is a Braille Translator, which basically takes directly the word in any language, between English and Danish, and takes it onto a robotic toolpath. This is the first test here with Lena, which we took at the National Institute. It's spelling out Droom, which basically means dream. And this is where I got my first slap on the hands, because that's basically not readable because the sizes were not calibrated right. So within that overall field, you can actually see what are the necessary dots that a hand can feel, because the pixel sits at the point of your fingertip. So it's also in size something that's relatively to your proportional body. Another slap on the hand was this thing here. We took Hans Christian Andersen's Little Mermaid and translated that into robotic Braille spelling. The problem here is that a blind person would not understand the directionality. They might not even have an understanding of what that text actually is supposed to simplify, because some of these points are way too discrete. So we were advised to move it relatively fast into raised Braille dots and images. So here's basically the pattern or the toolbox that we have. This is ball bearings, which can be inserted in the original robotic routing of the code. And then you can produce something that's as simple as this chair here, which can be used for literacy in the sense that spelling can be done by someone from a teacher towards a student and vice versa. The second script that we developed is basically taking a pixelation of a bitmap, not dissimilar to regular printing, and translate that towards a customized image here. So you can take any of those, increase the contrast, take it to a robotic toolpath, increase the depth. No, time is up, I'm rushing through. And you can also then produce something that is a double surface. So you both have the visual capacities for someone to see the smiling child here, which is completely meaningless to someone who's actually reading that through tactility, but you have the spellboard that's interacting with that surface. So basically what you have is a sort of integrative surface that combines different capacities from two persons with distinct abilities in the same and in a very universal design. So we wanted to know if that research is actually working for designers, because what I'm interested in is not actually to only create the design, but to create processes and protocols that can be inhabited by other people. So we basically set that up. So here the project dimensions and the parameters are a chair of 45 height. They got a joint library that they could work with. They could inhabit these protocols. They were asked to produce something that was both valid in a tactile narrative and in terms of Braille and in terms of the images that's been produced. We established these pattern samples as a tactile archive that moves between taking a photographic image, taking a line drawing, moving that line drawing through different stages of either line tracing from cut or from Rhino towards more discrete and decreasing grasshopper patterns in order to develop that logic. Then the second step moved towards skip over the textile exhibits. I know, I'll skip that. And so here's the things that are coming up. So the first project that these designers develop within 2 weeks' time is an alphabet chair as a learning practice for different for younger students. The second project dealt with the idea of perspective, which is not very much researched yet, looking at different possibilities of how to explain something like a cube and its different outline boundaries and the depth of perception in it. The third project deals with the idea of making haptic and tactile something that blind people can see, which is basically the grain pattern that appears in the wood surfaces themselves by engraving them over. All the projects were developed as chairs because the chair in itself is something that's shared by all of the cultures, and as a multiple, it can literally become something that creates community. Another project here deals with the idea of topography, where the CNC topography is actually cut for the underside of the chair itself, and then a couple of different topography in the sense of the mountains and the river, and then a couple of discrete patterns that were tested first, actually talked about growth and dynamics and flowers and botanicals here. The last project actually deals with the complexity of these different robotic fabrication protocols. So first routing out an image, then routing out different descriptions and points so that you have a cartographic map that enables a spatial understanding for someone who accesses this chair before actually going out into the city. So the harbor itself is a negative surface, and then the rest is a tectonic where relationships between different points can easily be shown. A couple of the images of the exhibition itself. Future research, and I think this is quite interesting because the point becomes the description, but the point also becomes the topography and the spatial mapping and the landscape. So these pixels can be interpreted in different data. But the reason why we're making that, and I think this is really important to me, because been sort of continuing to think about the question is, what do we teach the digital natives? What do we teach the people who are actually learning digital pedagogy now here, who will be completely fluent in computational design and all the different fabrication purposes? And I think what we have to teach them is why we're doing these things. And we have to also teach them empathy. So here's a couple of the things that EBOS, the National Institute, uses in order to give people who are not blind an understanding of how that is limited with all these different tools. And the way how we are going to continue further with EBOS is we're going to take these sample studies through a Leica test with a user group of 5 people. We're going to develop teaching materials with them that can act as as tactile representations of the reality that is surrounding them. We will support them in that further within educational standards, and we will, at the moment, and I think that's quite exciting, but that's going to be some other talk for some other conference. We're actually going to working on speech recognition for the robot, so that blind people cruising through an urban environment actually have the possibility to speak into a wall, while the robot then puts these Braille patterns on there, which will be quasi a graffiti and a communication to someone who's bypassing within that urban space. Sorry for running over. Thank you very much.
Thank you very much.